All right, so we are day 2 on 2.2. We're going to do regression stuff, but this is from last night's homework. Those 3 questions were assigned. We didn't talk very well about the leading term test yesterday. The leading term test is the test that tells whether it's going to open the end behavior. And so the leading term tells us we need the degree and what the leading coefficient. Yes. So that's really easy on a question like 40 right here. You would say that's degree 3 with a leading coefficient of -2. So it would be going this way. Okay. But it's more complicated when you have a question like 34 or 36. Can anybody tell me the degree and leading coefficient of this one? I don't want to FOIL that all out, do you? Yeah, but if you just look at the x's, you're absolutely right. There's an x and an x. That would make what? An x squared. And there's an x squared out here, so we'd have an x to the 4th. And there's no leading coefficients on any of those, right? So it would be that shape. At least both ends would go up. What about 36? There's an x. This would become an x squared. Can you guys see that? And then a 2x. So we have a 2x, an x squared, and an x. Would that make us a 2x to the 4th? So it would still be going this way? I don't see any complicated ones there. Okay, the second thing is determine the zeros and state the multiplicity of any repeated zeros. Yes, so let's do this number 35 right here. What are the zeros? Because it's already factored. -x equals 0 means just, and that's just multiplicity 1. You don't even have to write that if you don't want to. This one is, okay, -3, and that one's multiplicity 2. Everybody gets that? Okay. And x minus 5 would be 5, and that one's multiplicity 1. Okay. What does the multiplicity tell us? Yes, and it tells us whether the graph does what? Yes, a cross or a bounce. Are you guys okay with me using the word bounce? So an even multiplicity means it's going to bounce. So if I were to attempt to graph this now, by the way, this one was a degree 4 with a negative leading coefficient, so both ends are down. So at 0, it's going to cross. At -3, it's supposed to bounce. And at 5, it's supposed to cross. So it starts from down here because of the leading coefficient. It bounces, crosses, crosses. All right, does that help you understand those directions and what you're supposed to be doing there? You guys can use your graphing calculator, but I got to tell you, on some of these, in your little window, you're going to see this. Do you know what I'm saying? It's going to be like a mess until you fix a window. So if you know what's going on ahead of time, it will help. All right. Anybody else have homework questions? All right. I'm going back and do this warm-up. Tell me how to start, because this did not go well on the quiz. I have to square both sides. Which one is going to come out really nice? Yeah, when it's all under the radical, these undo each other, and I just get 4x plus 13. But over here, I have to, yeah, I would call that a FOIL, but I have to square this quantity by multiplying it all out. So I get 4x plus 13 equals square root of x times square root of x is x. But then inside and outside are each what? 4 square roots of x. So if I add those together, I have 8 square roots of x. Everybody okay with me adding them together? And then 4 times 4 back here is, okay, now what? Now we need to isolate the radical again. This one we couldn't isolate it, so we left it 1 on each side. Okay, if we subtract an x over here, and the 16 while we're at it, we'll have what? 3x minus 3 equals 8 square roots of x. Now, we're going to need to square both sides. Do you want to divide the 8 over the other side or not? I would probably do not, just because it's icky. Okay, if we square both sides, what do we get on the left? A mess, right? 9x squared minus 9x and another minus 9x would be minus 18x plus 9. What do we get on the right? 8 square roots of x times 8 square roots of x is 64 and an x. Everybody with me here? Okay, now what? It has a quadratic, so I don't know how to do that. I have to either quadratic formula, factor, something like that, so I have to get it equal to 0. Somebody help me. What is that, 82? Where is my cursor? Oh, that was weird. It just like 9x squared minus, is it 82, guys? 64, yeah. 72, 82x. Ooh, I think we might be good. If we do 9x here and 1x here and put this 9 here and this one here, won't that give us 81? And one more would be 82, and it turn out, okay. So we get x equals, if 9x minus 1, I'd have what? 1/9 or 9. Okay, what's the big deal about these? Half an hour later. They could be extraneous. 9 was one of them. If I put a 9 here and a 9 here, 36 plus 13, 49, is that right? Square root of 49 equals square root of 9 plus 4. Does that work? The other one was 1/9. Okay, I need somebody with a calculator. 4 times 1 divided by 9 plus 13. Math, enter. Underneath the radical. Yes? You didn't square it yet or anything? You didn't square root it? You did square root it? So after you square rooted, it was 11/3. Okay. Okay. Over here, it's a square root of 1/9, which would be what? Guys, you should be able to do that in your head. Yes. 1/3 plus 4. I don't think that works. Because that would be 13/3, right? So it doesn't work. So only the 9 worked. The 1/9 was extraneous. Okay. Do we need to do more factoring practice on any of these? Yes, I'm seeing some nodding. What do you do when it has only an x4 and an x squared? And this one doesn't have any x's, right? We can't take anything out, but we can do what? X squared and x squared. 1 and 3 both minus, right? Would make a -4 in the middle. Are we done? This one does not go further, right? Okay. On the homework, you had to then find the real solutions. How many real solutions does that have? Well, one of them is -1. One of them is +1. And here we'd have x squared equals 3, so x would be plus or minus the square root of 3. Those are real, yes? There are 4 real solutions. Okay, what do we have to do to the second one? There's 4 terms, so try grouping. What can I take out of those 2? And out of the second 2? Oh, interesting. Because what should I have probably done first? What do they all have in common? They had an x. All right, but anyway, if I take out an x plus 2, the leftovers are an x cubed plus x, which we just decided we should take an x out of. X squared plus 1, going to go further? Does it have real solutions? X squared equals -1. If you set that equal to 0, you with me, Martin? X squared plus 1 equals 0, you'd have x squared equals -1, and then when you went to square root, a negative would be I and negative I. So those are non-real solutions. So the only real solutions on the homework would ask for real, you'd have 0 and -2. Everybody good with that? Where the 0 came from? Okay, we're going to do this one correctly. What can we do first here? And then we'll have which factors? How'd I do? How many real solutions? 0, 4, and 5. Last one. X squared and x squared, factors of 8 that make 2. Does that work? Okay, how many real solutions? It's not completely factored, right? But that it still gives you those 2 solutions. And these two, this one does not factor further. If you set it equal to 0, you'd get square root of a negative. So it only had 2 real solutions. How could you double check that if you were doing a question and you want to know how many real solutions it had? But if you graph it, a real solution will show up on the graph how? As a 0. It will only have 2 places that it crosses. All right, ready? Calculators fired up. Today, what did we do last time we did regression equations? We did this number 4, right? And we're going to revisit that one a little bit today. There are some of our data that could be linear, but we are also going to talk about 3 other ones. Okay, if we had data that looked like this, we would definitely pick a linear regression, right? But if we end up with data that looks like this or like this, would a quadratic regression maybe be okay? What shape would a cubic regression be? Yeah, if it seemed to be like slowing down and then, okay, either one of those shapes, most likely the first one. And the other one we're going to do today is a power regression. To find the power regression, you're going to have to scroll down on that list because it's hidden underneath, okay? That's what this little arrow over here means. There's more. So if you scroll down, you'll get to this power regression. And a power regression does this, okay? Goes up and keeps going up very quickly. All right. Now, one more thing before we actually get started. When we had a question like this, predict something for 1980, and it was years since 1900, and you had come up with some nasty equation like this. Do you remember what you had to do? You had to like put 80 back in here and find an answer. And it was okay to do that by hand. But starting today, you have to save it with all its multitude of decimal places into Y1 and use that. Okay? Is everybody hearing me? Because you're going to get a different answer if you don't do that. All right, so the first example we have today, you can type these in if you want, but feel free just to watch this one, okay? Because it's just a lot of data typing today. An oil tanker collides with another ship and starts leaking oil at the rate shown in the table. So after 1 hour, it's leaking this many liters per hour. Then it gets worse and worse, but then it starts to slow down the flow of the oil, okay? So I put the information in, because I'm just that ready today. I put it in list 1 and list 2. Now, does anybody remember how we could look at it? How do we look at the scatter plot? Because that's what you're going to need to be able to do today. Does anybody remember at all? You have to turn a plot on. So it's second y equals, and I have mine in list 1 and list 2 to make sure it's on. And then I pick the first one as the scatter plot. And then I have to do a zoom 9, and it looks like this. Okay? We're going to do this all together again in a second, but you might want to write down those steps. It was stat enter to enter your data in, and then it was second y equals to turn the stat plot on, and then we have to remember we did a zoom 9. Okay, those are the steps I would be worried about you remembering. Everybody okay? Sorry. Now, what shape is this one? Yeah, it's looking like a parabola. So we're going to go stat over to calculate, and then it is a quadratic, we're thinking, so we're going to pick choice 5. Now, I do have this one in list 1 and list 2. Some of my other ones you're going to have to help me remember today because I put them in different lists. You don't ever want anything in a frequency list at this point, and you want to store it. I learned a shortcut. Do you remember the whole vars thing and arrow to the right and a million buttons? If you have one of these calculators, if you go alpha trace or alpha F4, it gives you all of them. So you can just hit enter. Just saved you 1,000 buttons. Okay. If you don't have this calculator, it's under vars, arrow to the right. I'm sorry. Arrow. Try again. Vars, arrow to the right. Enter, and then pick one. Okay, but I don't want to do that. And then I'm going to calculate. This is the screen I get. Uh-oh, I don't think my diagnostics are on. Can anybody tell me how to do that? It's under mode. Down here it says stat diagnostics. And I want to turn that on so that I get some R values. Now they won't all give you R values. It depends on if it can calculate whether it fits well. Now, I got an R squared value for this one, okay? But it is very close to 1. And if I look at the graph again, you think it's a good fit? Okay, so let's go back to the question. This is what we got on the calculator. And to get this answer, we did stat, right arrow. We chose quadreg. And then does anybody remember the shortcut to the, it was alpha and F4, right? Is the trace to find the y. That was our new shortcut. Okay, write a polynomial function. So it gives us this. Does everybody see right there? And we're supposed to put these in, and it says to the nearest thousandth, which would be tenths, hundredths, thousandths, 3 places. So A is negative 0.409. You have this on your sheet. X squared plus B is 2.762x plus C is 16.267 if I round that to 3 places. And the correlation coefficient is about 0.993. This is the only correlation coefficient you can get for a quadratic. And I don't know much about how you calculate a quadratic correlation coefficient. All right. We are supposed to then use the model to estimate the flow in 10.5 hours. 10.5 hours would be an X value. So there's 2 ways you can do that. I hope you're paying attention here. You can trace to 10.5 if You have to go trace and then up arrow so that across the top here is that saved equation. And then you can go to 10.5, but only if it's in your window. It is in my window just barely. I got 0.1698. Okay, sometimes it's not in the window and then you got to change your window. But the other way, everybody do this. Can you go to second window, and then change it to Ask Auto again? We did this before. Second window, Ask Auto. Martin, second window. Everybody needs to do this so that later when you're doing a question, it's in this mode. Second window, Ask Auto. Now, because I have saved it, when I go here, it has an equation in Y1, and if I put in the 10.5, I get that decimal again, 0.1698. All right, so since Y equals 0.1698, now go back and look at the answer. Was it just, this was hundreds of liters per hour, and they want liters per hour, so what would we have to do? If we want to get rid of the hundreds label, we got to move it. Yes, over 2, right? So it would be about 17 liters per hour. All right, D says use the model to determine the approximate time that the flow was 1,000 liters per hour. Well, 1,000 liters per hour would be putting in a 10 for Y, right? Because we divide by, was it by 100, yes? Yeah, okay. I'm right. It says here to use Y equals 10. There's not one like that on the test, but if you go to the graph and you put in at another spot here, Y equals 10, and then we find the intersection point. So about 8.5 hours after we started is when it had slowed back down to 10, or what is equivalent to 1,000. What did I just say it was, guys? 8.5? About 8.5 hours later. All right, and for that one, we put in Y equals 10, okay. On the intersection. Ready? Here we go. I'm going to pause the video while you type these in. Okay, how do you get to the list again? Stat, enter. Okay, stat, enter. Put in list 1, the distance in, I believe it's astronomical units is what it's called. It's the distance from the sun to the earth. And that's 1 astronomical unit. That's why the third one is 1 for Earth. So put all those in list 1. And then in list 2, you're going to put in the days it takes to orbit the sun. You should recognize the Earth is 365. Okay, so once we have them typed in, what's the first thing we should probably look at to decide which regression is going to work? We need to plot them. Do you remember how to do that? So I'm going to go to Y equals and clear this garbage out. And then I'm going to go second Y equals, enter to turn the plot on. Make sure it's the right lists. Yours are list 1 and list 2. Mine are actually list 3 and list 4. So I don't want to delete this before next hour. And how do we get a nice window? Zoom stat, which is choice 9. Okay, anybody got this? Now, at first I was thinking linear. But if you look down there at the bottom, there's a bunch of points that are not on our line, right? If we were to draw a line through the rest. So just like on the quiz, I'm actually going to tell you what to use. This one says we should use power regression, okay? I'm not going to make you decide. I will tell you which one you have to use. So power regression is what we're going to use. So we go to stat. Did everybody get the graph to show up? Martin? Did you get the plot? Okay. Stat right arrow. How do we find power again? Yeah, we have to scroll down because it's not in that screen. It is choice A on the next screen. Did everyone find power? Okay, and yours should say list 1 and list 2. I have to change mine to say list 3 and list 4. And then we want to store it. We always want to store it today. So the shortcut is alpha trace. I'm going to do it the long way because some of the older calculators don't have the shortcut. It's vars, arrow to the right, enter, enter. And if you have the older calculator, it actually will look, it could look like this, or you can just type the Y1. You don't even need to type the L3 and L4, right? Just as long as you store it. Okay, then you hit enter. Did everybody get an R? Anybody need to go back and turn their diagnostics on? All right, so I'm going to put this screen on here so that we can use those numbers. All right. Didn't get those? Okay. All right, so we fixed my list. I had a number in wrong. So again, real quick, it was stat, right arrow. We went down to power. Whoa. Oh, Lord, I'm so... I always get trouble when I do that. I push something wrong. Okay. And the shortcut was here. All right, now it should overwrite and fix my equation. Is this what you guys had? That's good because that's what I had. What is that? Okay, go back here. This is what we're supposed to be doing. This is what I had last year when I did it. It's right down here, okay? So we are going to write down to the nearest thousandth our equation. Notice the form this time. It's A times x to the b. So A is 367.323. Yes, if we round to 3 places. And then it's times x to the power of b, which is to the 1.501, I guess, if we round to 3 places. Okay. And the correlation coefficient is just the bottom one. I don't know, 0.99989. Yeah, it's just long. It's about 1. By the way, if we went to the graph, we should be able to see it graphed there.
Do you ever get a correlation with 1?
Certainly. Certainly. Just means that your data points are exactly on there. So when Hofbauer makes up an equation and then makes up data points, I could make them exact. Most of the time, it's going to be a pretty good fit because I made the points up in the first place to fit it. So that's all we had to do on that one, yes? There was no predicting. Let's predict. What if we were to find a planet another out at 50 AU? Can we predict how long its year would be or its trip around the sun? How would we do that real quick? Yes, but you want to use your saved equation, okay? So go second graph and put in 50. And I got 130,188 of our days would be a year. I would be much younger. Okay. We are moving on to example 3. I'm going to pause the video again to type these in. And while you guys are typing them in, this time I'm going to proofread mine, okay? If we have them in, what is the first thing we want to do? If we didn't know, if I was doing my homework and I hadn't been told what regression to use, I would need to look at the graph. So I go back second y equals because I have to change mine. because I have put them now in list 5 and 6, but you can still leave. Whoa, whoa, whoa. Oh, Hofbauer, you're scary. Okay, list 5 and list 6, but then we do a new Zoom 9. First, I'm going to go and erase my y equals equation, and then do a new Zoom 9. Oh, what's that kind of look like it could be? A cubic? A cubic? So that's what I decided to use. So what would we do next? Stat. Over to calculate. The cubic regression is what number? 6. And mine are in list 5 and list 6. Yours are probably in list 1 and list 2. Again, I'm on the wrong line. Okay, I want to store my equation again. So vars, arrow to the right, enter, enter, or use the shortcut. Calculate. It is a lot of numbers for a quadratic. Did you get something like that? Okay. Mine matches what I got last year. What else is true? Oh, I would have got this wrong probably if it was a quiz. What do you see about those numbers? Anybody notice this back here? Yes. It's A is negative 3.87 times 10 to the negative 8th x cubed. But you can't make it 0 because then there won't be an x cubed. And it's plus B is 1.53 times 10 to the negative 4 x squared, plus C is actually minus minus 0.136. I'll go 3 places on that one. X plus D is 167. I'm going with 167 because I'm out of room. Okay. That one is icky. Let's see how well it actually fits. If I go to the graph. Oh. It fits pretty good, but it does dive down at the end, doesn't it? So if we were to use that, by the way, I didn't read what the question was. Amount of food energy produced by farms increases as more energy is expended. The following table shows the amount of energy produced and the amount of energy expended. Okay, predicts the energy output when the input is 800 calories. So I'm putting in 800, so how do I do that? Oh my goodness, what did I click on? There we go. Second graph, 800. Is that what I'm supposed to be putting in? Okay, I got 136 roughly calories of output. That fits the data though, right? 800 would fall in here and 136.5 or something would fall in there. Was it 0.45, guys?
Yes.
Okay. And that was calories of output. All right. So your assignment tonight, these 3 are regression equations to find. And then the rest of this is some review of concepts we did yesterday, okay? These are the homework questions. Oh, real quick. It says, the first one looks like this. What would you put in here instead of January? But be careful. There's no July, or no June. 7, 8, 9, 11, and 12. Because then it does ask you to go back and put in a 10, okay? So be real careful when you type those in. And do type them in. Do the homework. Okay, so one more time, here's the homework. I already told you this, right? That we're gonna have